Namaskar, welcome to PK's classes. Today we will study hypothesis testing. Before we discuss that, let us recall what is experiment. Experiment is the process of research in which one or more variables are manipulated under conditions which permit the collection of data. So, we manipulate one or more variables so that the researcher can obtain particular data what he or she needs. So in other words, we can define it as a process which creates an artificial situation to obtain particular data needed and to measure the data accurately. So the artificial situation, what does it mean? Suppose we want to screen a new drug, a synthetic drug or say plant-based drug for its anti-diabetic activity. For that, we will take some animals, we will induce diabetes by injecting say streptozotocin. So we are creating an artificial situation and we will conduct the experiment. And experimental studies are nothing but the hypothesis testing research studies. So you can say experiment is the process of examining the truth of a statistical hypothesis related to some research problem. And it is not possible to conduct the experiment in the whole population. So we take a sample population. Instead of the whole population, we take a sample population and conduct the experiment. Suppose in the above example of screening the anti-diabetic activity of a drug, say we divide the animals into 4 groups. So control, negative control where we will induce diabetes by streptozotocin only, and say standard group, standard plus streptozotocin, and the test group streptozotocin plus the test drug. So 4 groups means we have 4 sample populations taken from the whole population. And in this we can take 2 types of assumption. The first assumption, the parameter, say mean, the population mean is same as that of the sample mean. So the population mean is same that of control mean, population mean is same as that of the negative control mean, population mean is same as that of the standard drug, population mean is same as that of the test drug. In other words, the means of all the sample populations, are same. This can be one assumption. That means all the sample populations are representing the whole population. This is called null hypothesis, this type of assumption. And the other hypothesis called as alternate hypothesis, which is just opposite of the null hypothesis, where we say there is a difference between the whole population and the sample population. So we can say there is a difference between the control and negative control, control and standard, control and test, test and standard, negative control and standard, negative control and test. Between the groups there is difference. That is alternate hypothesis. But when we assume that there is no difference between the sample populations, all are coming from the same whole population, all are representing the same whole population, then that is called null hypothesis. So hypothesis is nothing but an assumption that we make about a population parameter, say mean, a quantitative statement about a population, and to test some hypothesis about parent population from which the sample is drawn is called hypothesis testing. So we take, that means in case of hypothesis testing, we assume that the samples represent the whole population, the sample mean is same as that of the population mean, and when we say multiple samples, so say group A, group B, group C, group D, and all these groups mean are same as that of the population mean, that is null hypothesis. All these group means are different and they are also different from the population mean. When we assume that, that is alternate hypothesis. So two types of hypothesis: null hypothesis H0, alternate hypothesis HA. Null hypothesis, there is no real difference in the sample mean and the population mean. And when we have multiple samples, say A, B, C, D, so all will have same mean. That if we are assuming, then that is null hypothesis. And when we reject the null hypothesis, then we can conclude that there is a significant difference between all these different groups. And when we compare individually any two groups, and then we can say, suppose in our case B is the negative control, only step 2 solution is given, and D is the test group. So when we compare B and D and we find significant difference, then we will say, yes, this test drug is having significant antidiabetic activity. So in the initial stage, we have taken the null hypothesis that there is no difference in the mean of all these four groups. That means B and D have no difference, we have assumed. But when we reject that, that means there is significant difference. This is all about hypothesis testing. And the alternate hypothesis is just the opposite. We are assuming that there is difference in the sample mean and the population mean. If we have multiple samples, then there is difference between all the means of all the samples. That is alternate hypothesis. So during the testing of hypothesis, we can come across two types of error, type 1 error and type 2 error. Type 1 error is also called as the false positive error. Why? Because in actual, null hypothesis is true, but we have rejected it. So it is called false positive error. And we usually measure the probability of type 1 error, and based on that we can say what is the level of significance. Alpha is called the level of significance, which is the probability of type 1 error. So alpha is the probability of rejecting the null hypothesis. Also we can say probability of accepting the alternate hypothesis. And the second type of error is the false negative error, that is accepting the null hypothesis when it is false. Or we can say false negative error is not rejecting the null hypothesis when it is false. And the probability of type 2 error is called beta. So beta is the probability of accepting the null hypothesis and or rejecting the alternate hypothesis. And 1 minus beta is called the power of the test. So in hypothesis testing, we usually take the null hypothesis and we then calculate the probability of the type 1 error, and from that we can say what is the level of significance. So this is the normal distribution curve, and the sample statistics should fall in the tails of this normal bell-shaped curve. And if it is the sample statistics is falling in 0.025 of area of the two tails, so total 2 into 0.025, that is 0.05, then we reject the null hypothesis. Otherwise, we accept the null hypothesis. So this is the mean. So you generally the level of significance is fixed at alpha 0.05. So p less than 0.05 is generally fixed, and if in the two tails it will be still lesser than 0.025, say 0.005, then it will be p less than 0.01. So the chance of the probability of type 1 error is 1 in 100. It is usually expressed in percentage. So in p less than 0.05, probability of type 1 error is less than 5 by 100. So in p less than 0.05, the probability is 5 by 100, whereas in p less than 0.01, it is less than 1 by 100. So when p is less than 0.01, the level of significance, it is more significant than p less than 0.05. And when we say p is less than 0.0001, that means at each tail 0.0005, so it is still lesser. So in that case it is more significant. So p less than 0.001 is more significant than p less than 0.01, which is more significant than p less than 0.05. This is the minimum, and if p less than 0.05, then we can say it is significant. Suppose this is a t table at a certain degree of freedom. You can refer to our earlier classes on degree of freedom. And at a certain degree of freedom, we will suppose choose p less than 0.05. We will have a table value, and we will also get a calculated value. We will calculate the value from the data. So the calculated t value can be either greater than the table value or less than the table value. If calculated t value is greater than the table t value or critical t value, then we reject the null hypothesis. So in case of any two groups, we usually use the t-test. So suppose in our example, we want to compare between the negative control and the test, between the standard streptozotocin and the test drug. So streptozotocin has induced diabetes, and now test drug, whether it is reducing the blood sugar or not, we want to check. We will compare it. We will apply the t-test, and from the data we will calculate the t value. So we will have a calculated t value, and from the number of animals taken in that group, in the two groups, say 6. So degree of freedom we can calculate, and degree of freedom is n1 plus n2 minus 2 in case of, say, students t-test. So at 10, suppose 6 animals you have taken, 6 plus 6 minus 2, 10. So at 10, the table t value will be 2.228. And if our calculated value is 2.3, then we can reject the null hypothesis. That means there is a significant difference between group B and group D, and our drug is having significant antidiabetic activity, that we can conclude. So this is all about hypothesis testing. Thank you.